Hey, good morning, guys. Hope everybody's doing well. Today, we're just going to wrap up the first portion of our chapter dealing with the sensations of the human body. So, we've talked in fairly decent depth about the idea of the eye, which is obviously the human sensation of sight. We've talked about the ear, which obviously deals with the sensation of hearing. Today, we're going to kind of focus on what they call the secondary senses, or the three other remaining of the five main senses. So, we'll start with the sensation of smell, then we'll get into the sensation of taste, and then we'll wrap up with the sensation of touch, which kind of encompasses a number of different things, whether it's the idea of texture, whether it's the idea of pain, pleasure, temperature, pressure, all of the above, all of those things that we kind of deal with our tactile sensation of touch. But before we get into those secondary senses, I do want to just briefly talk about one remaining item when it comes to hearing, and that is the idea of, well, what happens when you do not have that sensation, otherwise what we call in the common world is deafness. Now, there are two types of deafness. Deafness type number one is known as conductive deafness, which basically just means that you have a limited ability for the processing of those vibrations. So normally, this is going to be a whole lot more, we'll say, likely that you will experience this because this happens due to injury, blunt force trauma, old age, just overuse in general. So basically, this is the portion of the ear that is receiving those vibrations or making the vibrations when we deal with the small bones inside the middle ear, and something, whether it's a defect, whether it's an injury, whether it's just the inability for it to process, that happens normally in that middle to outer ear. So there's a number of ways that we can get around this, whether it's, correcting something to do with the tympanic membrane, which is the eardrum. Maybe there's a hole in it. Maybe, there's scar tissue on it for whatever reason that diminishes the ability for you to have that reverberation. Or maybe it's, the breaking of the small bones, or maybe even it's just too thick of the kind of encasing fluid that centers in the middle ear. All right. So all of those things can obviously impact how well or to what amplitude you can hear those sounds. Now, normally we treat this with hearing aids, but we can also treat this with surgery, whether it's some sort of corrective surgery dealing with, replacing the eardrum from maybe a cadaver, or maybe it's the reshaping of the bones. We can do pretty much anything and everything we need to do, with the exception of your biology. So what I mean by that is sometimes there are individuals that have extremely thick middle ear fluid, all right, and that doesn't necessarily allow those sound waves to transition cleanly through the middle ear. So sometimes through medication, we have to thin that out, and that will allow for a little bit more crisp hearing. Doesn't happen in a large portion of individuals with conductive deafness, but it is something that does actually happen. Now, the other type of deafness is a little bit more psychologically related. This is known as sensorineural deafness. This deals with the more acute injuries of the brain / the inner ear. So these are the things that typically are damaging to the specific structure in the inner ear known as the cochlea. That's the snail shell looking thing that contains the very, very sensitive hair fibers that are finely tuned to certain frequencies. All right, they kind of operate. Maybe the best reference that I've ever heard used is maybe a piano or maybe a harp. Each of those strings has a certain frequency. Same idea with those hairs. Those vibrations pass through the cochlea. When that vibration that matches with that specific hair, all right, happens, it tingles the hair, and then the signal goes from the hair into the auditory nerve. So if there's any type of damaging nature to it, whether it's injury, whether it's illness, disease, just biological structure, all right, that's typically what happens. We also see this especially in younger individuals where there isn't necessarily the fully forming of the inner ear. All right, so typically if you see a small child, a baby that comes out with complete and total hearing loss, normally it's something to do with either the cochlea or the actual auditory nerve. And the way that we get around that is through the invasive surgery that's known as a cochlear implant. What this does is it uses a microphone in this little area right up here. All right, you'll see actually what a real cochlear implant would look like. There's a small microphone that uses bone conduction to basically transmit a signal through an implanted wire that directly connects into either, in some cases, it's the auditory nerve. In some cases, it's the thalamus. More often than not, it's the auditory nerve. It just basically bypasses the entire structure of the ear. All right, you then get that nice, clear, crisp sound. It's easily translated by the brain, and we eliminate any portions of kind of that assembly line of sound that normally comes from fully the surface, the ear, all right, and the auricle all the way through the inner ear. So any way you slice it, deafness, obviously it affects a large amount of people, but in today's day and age with the use of technology, translators, ASL, basically anyone that has some sort of hearing loss or complete and total profound deafness, they're able to operate completely normal, just like their unaffected peers. So we've really seen the ability to communicate expand into the workplace and everything else, social life. These individuals lead a completely normal life for an extended period of time. All right, their life and the quality of their life is not impacted nearly as much as it was just a decade ago, 2 decades ago. And individuals that would be profoundly deaf for their entirety of their life now have the ability of hearing. So getting into just briefly the final of our senses, we're going to deal with smell first, taste, and then the skin senses, which is the sense of touch. So with the sense of smell and sense of taste, what we're dealing with is psychologically and biologically the nerve known as the olfactory nerve. Now, the olfactory nerve is kind of a combination of our taste buds as well as the scent receptors in our nose. So what this does is it just generally transmits a signal based off of what you're experiencing directly to the brain, right into the hippocampus. What is unique about your sense of smell and sense of taste is it completely bypasses where all other sensations go to, which is the thalamus, and it goes directly into the middle portions of the brain, into the midbrain. All right, so it's directly in there, and because of that, this is one of the most acute senses that the human body has. All right, because there is no filter, because there is no telephone game happening here, our sense of smell and our sense of taste is highly connected to our sense of memory as well as our sense of reality. All right, so that's why we have such a very strong reaction when we smell certain things, good or bad, as well as when we taste things, good or bad, because we commit it to memory and it is hardwired into the midbrain. But with that being said, it is also the sensation that is going to be easiest for sensory adaptation. Your body will naturally, because it's dealing with so many scents and so many tastes simultaneously, it starts to filter those things out based on previous experience. All right, so early in life, everything is new. So, small children, adolescents, babies, they have a very narrow band of taste buds, but it's extremely intense. So things that taste extremely bland to us, it tastes very likely very flavorful to them because it's the first time they're experiencing it. All right, that's why your taste buds change, quote unquote, change throughout life, because in many cases your taste buds either go dormant, all right, or your natural inclination is to expand your taste platform. All right, where they talk about, when you eat a fine meal, and they talk about taste profiles. As you grow older, certain profiles go dormant and certain profiles become readily more accessible to you. And it's not because you haven't had them your entire life. It's because now we're starting to trickle down to a little bit more of the more sensitive areas, all right, that now we're just being able to process. So when we look at taste, there are 5 different taste qualities that we deal with. I know the slide says 4, but the 4 areas are going to be the very unique taste buds, and then the 5th is kind of what allows us to differentiate, and that's called the savory taste. So the 4 basic tastes are sweet, sour, salty, and bitter. All right, and we have right at the tip of our tongue what is effectively known as the sweet and salty area. All right, so you're eating milk chocolate, you're eating caramel. All right, that's going to be felt right there on the tip of your tongue because that's where those taste buds are legitimately located. So you're going to have a very intense reaction, and then it passes deeper into your body and into your, obviously, food processing capabilities. So obviously when you chew it, All right, you're going to expose different things, and different taste buds are going to impact based off what you're eating, right, and the combination that you're eating. Then moving to the sides, this is going to be probably the most reactive area of your tongue and your mouth. That's the sour sides. So, we all remember when we had, our first warhead, we'd pop it in our mouth, you'd feel that kind of immediate, almost like fish face happen. All right. So the sides of your mouth would intensify. They would basically almost like seize up, right? As well as you would have that very crisp smell, taste combination right there on the side of your tongue. All right, and then we get to the back end of the tongue, which is the bitter side. All right, this is basically a fight or flight reaction. So the more bitter the taste is, all right, that's why it's closest to the gag reflex. It allows the body to expend it if it needs to. Now, obviously, we know certain taste, all right, they're meant to have a bitter taste. So, your body reacts differently based off previous experience. When you're a small child and you have your first bitter taste, all right, normally you regurgitate it because it tickles the gag reflex. And then lastly, all right, in the center of our tongue, we have what is known as the savory complex. This is more for the bland foods that we eat that allows us to differentiate. This is what allows us to tell the difference between buttered mashed potatoes and salty mashed potatoes, all right, because they're going to have a different taste profile. It's more of kind of like the glue to your taste profile. It allows you to kind of categorize and combine different profiles. All right, and the last thing on our taste buds, it's important to know that our taste cells are constantly not only being restored, but also being replaced. So what tastes good to you now, your profiles and your likes, dislikes, as an adolescent or as a teenager, likely will change as you go through your late 20s, your 30s, your 40s, your 50s, your 60s. And different foods will have different reactions based off of your biochemistry as well as previous experience. All right, so a great example is maybe there was something that was really, really unique that you ate as a small child, all right, that you can't stand the taste of now. All right, beets is always one that always pops up. People don't necessarily like that kind of earthy taste, once they've experienced all the different tastes. But beets are basically like crack cocaine for small adolescent children. All right, and that's because of their limited experience. All right, and it has a very flavorful profile when they are early in the life cycle. So lastly, we come to the skin senses. Now, this is probably the most complex of our senses, but it's also the one that kind of falls farther behind on that, I guess if you want to say, order of operations when it comes to the brain's gate theory. All right, and that's just kind of the categorization of what information and sensation your brain processes first. The gate theory specifically talks about, and we'll deal with this later, with pain, but it also is relative to all sensations that you deal with. So humans obviously have distinct receptors for pressure, temperature, pain, pleasure, all within the different layers of the epidermis of the skin. All right, so some of these need to be reacted upon much quicker because of fight or flight, because of self-preservation. Some of these things are going to be a little bit deeper in different layers of the epidermis because of, kind of like a last secure line, the last line of defense. And we'll talk more about that in a second. Pressure is that last line of defense. All right, it is the deepest skin neuron sensor in the body. All right, and it basically is there for self-preservation. All right, when those things get activated, all right, it's an immediate red flag, and the central nervous system goes into overdrive, typically releasing adrenaline to remove that stimulus from the body. So basically, that's the thing that allows you to tense up, get out of the car being crushed upon you, whatever it may be. All right, so obviously, certain parts of your body are going to be more sensitive to others, and the reason why is because you have more densely populated amounts of those neurons in those given areas. All right, so naturally, we know that there are going to be more sensitive areas on the body than others, and that's because of the essential need. All right, probably one of the most sensitive areas that we don't often think about is the lips. Obviously, we know that our fingers are going to have a lot of sensors. We know that our sexual organs are going to have a lot of sensors, but our lips are extremely, extremely densely packed because, all right, that is one of the earliest things that the human body is able to perceive the world with. All right, that's why babies pick up an object, all right, whether it's, a food, a toy, anything, and they put it up to their mouth because they're able to differentiate, because there's a lot more sensitivity there on size, shape, texture, pressure, pain, pleasure. All those different things are all right there. So that's why they basically experience the world around them, not only through sight, but through touch. So kind of starting to wrap up where all these sensors are. All right. 3 of the 4 major sensations that you feel with touch are all right there towards the top 2 layers of the epidermis, top 2 layers of the skin. All right. Pain is going to be the first thing that's activated. All right. We know that pain, obviously, basically it's enticing us or engaging the nervous system to do something. It's putting us into action. All right. Then we get into temperature gauges. So we have cold sensors specifically. We have heat sensors specifically. All right. And those activate based off of the general environment that you're in. And then we have our light touch. Now, not every area of the body is going to have an extremely large amount of light touch. The more light touch sensors you have, the more congested, all right, your sense of touch is, the more sensitive you become. But that also is a little bit of a double-edged sword, because those signals can easily be crossed, they can easily be misconstrued, and that's where we kind of get into that psychological kind of no man's land of, certain things feel negative to certain people and certain things feel good, pleasure to others, right, and vice versa. All right, so the combination of those 3 things, temperature, touch, and pain, are all things that are a little bit more experience-based. The strong pressure sensors deep in the 3rd and 4th layers of the epidermis, that's all about self-preservation. That's protecting the human body. All right, we want to protect the vital functions inside the body, whether it's the nervous system, whether it's the circulatory system, the things that are needed to survive. All right, and then we also have the sense of movement that comes from our hair follicles. All right, so the more hair you have, technically, the more movement ability you're going to be able to detect. All right, this is something that we don't often talk about because the social structure tells us you want to basically get rid of hair. All right, that is perceivable. All right, same idea. All right, that's why we have a little bit more of a duller sense of touch when we are hairless. All right, so this is a little bit of a caricature. All right, I can't be completely, we'll say, fully to scale on some of these things. All right, obviously, if I was trying to scale out our most sensitive areas, there would be some areas that wouldn't be school appropriate. So, all right, that's why he's got his pair of jorts on. But just kind of giving you a relative idea here, we know that the hands and the fingertips are going to be extremely sensitive. That's why they're enlarged. The tongue, the lips, the nose, all right, the face, the lower end of the face, all of those are extremely densely packed with a lot of these sensation receptors for touch. So as we talked about with temperature, temperature is all about kind of the environment that you're in. All right, there is a sense of sensory adaptation. All right, it's a fight or flight sensation. So, when we get into, too hot of water, all right, we immediately react to, okay, this is dangerous first, and we remove ourselves. But because of the subtle adaptation, all right, in theory, all right, we could get into lukewarm water and we could slowly turn up the temperature and we would not be able to perceive a difference. A great example of this, and this maybe isn't something that any of you have ever done, but if you've ever cooked shellfish, all right, or frogs, I know, all right, the reason why you want to cook them the way you cook them is because they have the natural evolutionary trait that when they perceive danger, they release a neurotoxin throughout their body, right? It makes the meat taste bad. So, all right, for instance, if you're trying to cook a crab or a lobster or a shrimp, all right, you begin cooking them basically in lukewarm water. You put them in a pot live, right, and then you slowly adjust the temperature, right? So you go from lukewarm water to not necessarily boiling, but warm water, and you slowly basically increase the temperature, and without the shellfish realizing it, all right, you basically are lulling them to sleep. All right, so effectively, you can boil these things alive, and they do not perceive danger because of the subtle sensory adaptation. Now, the human body in a vacuum would do the same thing, but naturally we have other senses that are able to perceive certain things. We start seeing bubbles pop up, we realize the water's boiling, we get out. All right, we don't allow ourselves to cook from the inside out. All right, but that's that's all kind of an evolutionary trait of fight or flight. And then lastly, where we talked kind of about the idea of pain and pleasure, all right, it's all about motivating us to take action, right? Either remove ourselves or go deeper into whatever the motion, the impact environment may be. All right, so the density of these pain receptors varies throughout the body. That's why you have more acute pain in certain areas. When you bang knees, you bang your funny bone, you get shot. All right, naturally, your body is going to process the level and the intensity of the pain based off how bad the injury is. So in theory, all right, the body is going to take care of the issue that is the most pressing issue. So say, for instance, you get shot and then you have a secondary or a second degree burn on your calf, you get shot in the chest or the burn on the calf, the body is naturally going to react to the pain from the gunshot than it is from necessarily the burn. So you may not feel the burn, but you're going to feel the gunshot. All right, we noticed this with firsthand accounts on like battlefields. All right, guys don't realize that they're missing half their arm because they got a gushing chest wound or something like that. All right, it's part of what is known as the gate theory. It suggests that the body can only process so much information at a certain given time. So basically, the nervous system makes an executive decision. It says we're going to handle this issue number one, and then we'll work our way down the list, right, as other things pop up. All right, so in theory, if we wanted to eliminate the sensation of a certain pain, we just have to create something that's more pressing issue. This is part of a psychological kind of idea, where you go into a doctor's office and they tell you to think about something else when they're giving you an injection, right? It's a little bit of out of sight, out of mind. It's the same basic idea, right? But we create a stimulus that's more important for the brain to take care of than the actual stimulus that is injuring you, right? So, they're going to have you look at a certain picture where your brain has to actively engage with the picture while they, give you the flu shot, something like that. All right, so this just kind of talks about that kinetic chain. So as we know, like when we talked about with the biological neuron and all of the different transitions of the electrical signals, the pain receptors, they're activated, the message passes to the central nervous system, whether it's the spinal cord or into the thalamus and the hippocampus. All right, if it goes to the spinal cord and they say, hey, we can handle this, the spinal cord sends out a direct reflex, right, makes the difference. Or if it goes all the way to the brain, then the brain can then release some sort of dopamine, some sort of euphoria, some sort of whatever neurotransmitter that needs to be released to compensate for the negative feeling. In this case, it might be pain. All right, it might be an endorphin, might send out dopamine, might send out a combination of anything. Adrenaline could be a great example, especially in a fight or flight situation. All right, so the last thing we'll talk about is kind of our body senses. This is more about the combination between sight and the sensation of touch. And the first thing we deal with is body positioning, balance. All right, and this is known as the vestibular system. All right, this is dictated by the middle ear and the fluids inside that middle ear. All right, so if we think about the middle ear, it's always going to be half full. All right, and that allows for that equilibrium for you to not only detect the direction and the change of direction, but also speed, forwards, backwards, ups, downs, and then your relative perception of reality around you. That's how you know up from down. And when you're upside down, you have that perception of something's not quite right. All right, this is all controlled by the inner ear, and it not only allows us to maintain balance, but it also, in a physical sense, allows us to maintain what we call kinesthesis. All right, which is your body positioning and the movement of your body in relation to the environment around you. So it helps you not only stay balanced, but it also allows you to avoid contact with maybe an inanimate object, to prepare for a body blow, when you're getting ready to run, full force into another person on the football field. It allows you to maneuver your body, right, to put your body in a position of strength rather than a position of weakness. Right. So all of those things are encountering multiple sensations at the same time, and it's based off of relative experience as well as your muscle structure and your nervous system. So, there's as much psychology that goes into your body motion as there is the physical side of, muscle training. All right, so that kind of wraps up the five basic senses. We'll talk about kind of the super senses a little bit next week when we deal with how we perceive certain things and how the brain processes. But in the meantime, there are two questions on Google Classroom I want you guys to answer. I would like for you to answer them just simply in a 5 to 6 sentence paragraph for each question. Nothing too big. I just want you to kind of dive into it in a little bit more depth than just simply giving me a sentence. So when you're answering those questions, create a Google Doc, all right, write out your answers. It needs to be authentic, all right? There is going to be an authenticity check. So don't just try and, copy something off the online. I want to hear your own words, right? I don't care if it's 100% right. I want to hear it from your perspective. That's the whole process and the whole purpose of the assignment. I would like for you guys to turn that in by next Wednesday at 11:59. It will be just basically a completion grade as long as you attempted it and it was logical. You'll get full credit. Other than that, hope everybody stays healthy, have fun, enjoy the time that you guys have to kind of, realign your chi, and hopefully we'll talk soon. The next online lesson will be next Thursday or Friday. They're adjusting the calendar. I think our schedule will stay the same as a Tuesday, Friday, but from here on out, we'll only have one lesson a week, and then we'll do some sort of socio-emotional on the second. So normally the Tuesday will always be our social-emotional, and our Thursday, Friday will likely be our new material stuff. So, have a great weekend, guys, and I will talk to you guys next weekend.